You're right, from here it looks like a circle because we're looking this way, but from there it's not a circle, right? Okay, so exponential growth is the next module. Module 4 is about exponential growth. So let's talk about some idea about exponential growth. Which of these functions is exponential growth? Which one of these functions is the purple one or the red one? The purple one or the red one? Which is exponential growth? Yeah?
Purple. Quick question. Is this stuff that's going to be on the exam or have we moved on?
Absolutely not.
Okay.
Absolutely not on the exam. So the last thing on the exam is inverse functions. Inverse functions. Okay? Which of these functions shows exponential growth? She wants purple. Agree? That's incorrect. These are both exponential growth. Okay? This is to expose. Mythbusters. Mythbusters. Myth number 1. If a quantity grows exponentially, it means it increases rapidly. It takes off. Right? This is how we talk about it. So whenever something's growing, accelerating, growing quickly, we use the term exponential growth. Right? People do this all the time. What they mean is it grows really, really fast. But both of these are exponential growth. So that's not what mathematically, that's not what exponential growth means. Okay? It doesn't mean an accelerating growth. Okay? Well, it does, but it doesn't mean it has to just fly off, whiz off to infinity. But that's how we use it all the time. Okay? So which of these show exponential growth? Okay? Neither. Okay. Myth number 2. Myth number 2. If it's a curve, it's growing exponentially. If it's curved, it's growing. Exponential growth is a very specific type of growth. Yes, it makes a curve, but there's a zillion other types of functions that make curves. So just because you're looking at a curve does not mean exponential growth. So our goal in this module is to understand exactly what is exponential growth. What are the nuts and bolts behind it? What very specific covariation between two quantities would we have that makes it exponential growth? Okay, so go. You've got your workbook. Go to Module 4, Section 1 in your workbook. Yes, sir.
What functions are they?
What are what? These? These are quadratic. These are both these quadratic, like x squared functions, x squared and polynomials. These are just polynomial x squared functions. Okay. But there's a ton of other types of functions you can write that give you curves that are not exponential growth. Okay. What page is that? 127, I'm hearing. So, yeah, I want you to do numbers 1 and 2. So 1 is this determining how many people learn the secret on day 2, and then fill out the table. So, or let's just do this first question. So how many new people learn the secret on day 2? How many new people learn the secret on day 2? So here's day 2. How many new people learn the secret on day 2? 12. So where does the number 12 come from? So where's the number 12 coming from? So go back even further than that. Where do we start, Connor? 3. We had 3 people. So that would be what? Times 2, right? So this is the number of new people on day 1. And then they all tell 2 people. So do you see that 12 comes from 3 times 2 times 2? Do you see that? That there are 3 people, and they initially know it. So on day 1, there'll be twice as many as that, or 6. And if they all tell 2 people, then there'll be twice as many as that. New people to learn the secret. On day 2, so that's 3 times 2 times 2 is 12. Okay, so here's then 3 different ways to express that number. Just 12 people, that's called decimal notation. Decimal notation is just the number 12. Product notation shows what we just wrote, that starts with 3, then times 2 for day 1, then times 2 more, times 2 again, to get the new people on day 2. And then exponential notation says that, hey, look, we multiplied by 2 twice, so we could use an exponent to show that we multiplied by 2 twice. So I want you to fill in the table. Fill in the table. Okay, let me get some help here. So, Sarah, how did it go?
On the first one,
Sure. 3 times 2 to the first. Okay? And then? Good. And then, how about the product notation here? Which is? Sorry, what'd you say? 2 cubed. Okay, let's come down to here. What's so funny? You don't like it?
No.
Why not? No, you just need a way to do it to show the meaning without writing all the 2's. How can we show the meaning without writing all the 2's? We can go like this: 3 times. Now, what would I write here? No, but why was he laughing? What would I write here? 15 2's multiplied together, so I can just do this. And then go, yeah, ellipsis dots, go do it like this, and then times 2. But then I should say, what is this right here? 15 2's. Same meaning. And then we don't have to write out 15 2's. We can express that that way. Okay? Exponential notation for that. Okay. So if we were thinking about this as a function with input and output, what would be the input quantity? Okay, what would be the input quantity? Okay? But quantity, right? Quantity is Measurable characteristic of an object. So, okay. She wants the number of days to be input, right? Yes. Okay? And what's the output? Number of people who learn the secret. So is that, which column is that? Is that the second, third, or fourth column? What is it? Which column is the output? All of them. Good, all of them. They're just all different representations of the same number. All of these are the output, the number of people who learn the secret. Okay, so what we have two things going on here. We have the initial number of people. What was that? What's the initial number of people? 3 people, right? And then what are we doing? Initial is 3. So what characterizes this growth? What characterizes this growth? So how can you summarize what's happening every day? The number of new people that learn the secret is, what is it? Cameron, what is it? So the number of new people that learn the secret, how does it relate? Double, right? So it's a doubling idea, right? It's doubling. Or multiplying by 2. So here's the question, and this is the key question. What's doubling? So use input and output to talk about how this is doubling. So is it, so choices are input and output. We're doubling what to get what? We're doubling what to get what? So, for instance, we're doubling the input to get the output. Or I'm doubling the output to get the input. Or maybe I'm doubling the input to get input. And the other choice left is I'm doubling output to get output. So I want you to talk about that. In terms of input and output of this function, it's doubling of what to get what. This is the whole ball of wax for exponential functions. Doubling what to get what. Talk amongst yourselves. Doubling what to get what. In terms of input and or output. In terms of input and or output. Doubling what to get what. Okay, let's see. Did we come up with it? Nathan, what do you think? Doubling what to get what?
Doubling output to get output.
He wants doubling output to get output.
You double the previous.
What's that?
You double the previous.
You double the previous output to get the current output. Valerie, agree with that? Aren't we doubling the input to get the output? Isn't that what it is? No, right? What's being doubled? The current output is doubled to get the next output. Okay? So doubling is this factor of 2. So 2, in this case, this number 2. So every time we advance the input by 1, we double the output, or multiply by 2. That 2 is called the growth factor. So what is exponential growth about? What is exponential? So that growth factor could be a half, it could be 3, it could be 8, it could be any number. Okay? That growth factor could be really any number. So what in general is exponential growth about then? What's that? Okay, be more specific than growing. What operation? Multiplying. Multiplying by a constant growth factor to get the next, what? Output from the previous output. So the growth factor is a multiplier on output to get the next output. This, and if that growth factor stays the same as you keep going, if you always multiply by 2 to get the next output, you have exponential growth. Exponential growth is about multiplication by a constant value to always get the next output by multiplying by that growth factor. That's what exponential growth is. Very, very specific way for the output to change. You pick a number and you keep multiplying by that same number to get the next output. That's exponential growth. Okay, come talk to me if you got a test conflict for tomorrow night.